afternoon, and welcome to Homework Hotline, the home of the Puzzle a Day giveaway. I'm Doris Johnson-Humphrey, and I'm here for the math segment of Homework Hotline. Today I'm going to be working with fractions, rational expressions, percent, and factoring trinomials.
I'm Robert Vriesman, and I'm also here for the math segment. Today I'm also going to be dealing with some fractions. It's kind of a fraction day today.
Yes.
All right. And, well, it's interesting. Rational expressions. Isn't that just another way to say fraction, Doris?
Radical expressions.
Oh, radical expressions.
Right,
Oh,
radical
radical.
expressions.
Oh, that's far more radical than rational. Before we get started, let's go to one of our English teachers. He's sitting there over at the phones. I don't know if he's patient or impatient. And let's just kind of ask Jose what kind of calls we have coming in today. Jose, what kind of calls do we have coming in today?
Well, first of all, I'm patient and rational. Hi, I'm Jose Hernandez, and just listen to those phones. If the phones keep on ringing, please be patient. We'll get to you as soon as possible. Now, if you have an English question, call and ask for me. Maybe we can do your problem live on the air. English comes in about 5 o'clock, so stay tuned now for 30 minutes of math with two very rational teachers, Doris and Robert.
Jose, what a radical thing to say. Remember, you can call in your questions simply by calling 1-800-527-8839 or just dial 1-800-LA-STUDY. The call is free, the help is free, so call now. And now, here's Doris.
Thank you, Robert. On today's show, we have another puzzle for our viewers, and the student who calls in the correct answer will win a special prize.
That's right, Doris. For the student with the correct answer, we have the travel edition of Where in the World is Carmen San Diego? This special version of the popular PBS game show can be played anywhere at any time. And the game includes 28 clue cards and instructions on how to play. Amaze your friends and improve your knowledge of people, places, and things with a travel version of Where in the World is Carmen San Diego? And be sure to watch Where in the World is Carmen San Diego immediately following Homework Hotline on this station. And now, back to Doris on Homework Hotline.
Today you're trying to find out the name of a person. I'll give you the first clue. If you don't get the answer with this clue, Robert, Jose, and Catherine will give more clues later in the show. Here's clue number 1. I first appeared in 1887. Again, I first appeared in 1887. If you know the answer to this clue, call 1-800-LA-STUDY and win the exciting travel version of the Carmen San Diego game. Remember, unfortunately, previous winners are not eligible. So now I'm going to be dealing with my first question that was called in by Jonathan, and we're going to be working with subtracting fractions. Jonathan,
Hi.
Are you ready?
Yes.
Okay, Jonathan, I have your problem on the board, and I'm letting people know that you are the person that's on the phone and you are our live call today. Jonathan is in the 5th grade, and he called in a question dealing with subtracting fractions. Okay, Jonathan, first of all, I want you to look at your top fraction, your top mixed number. Before we begin to do the subtraction, first I want you to look at this part. This is kind of odd. We usually don't get it that way, but you have a whole number and an improper fraction. So let's take care of this improper fraction part first, okay?
All right.
So we're going to have that 1, and to that 1 we're going to be adding something. So we have 7 divided by 3. How can you write this improper fraction as a mixed number? Do you know that process?
No.
Okay, we're going to divide our denominator into our numerator. So we're going to divide 3 into 7. What do you get when you divide 3 into 7?
2.
2. Okay, so that's going to be our whole number 2. And after you do that, 3 goes into 7 2 times, and 2 times 3 is 6, right?
Yeah.
And how much is left over?
1.
1. And so that 1 is now written over that denominator of 3. So 7/3 is really 2 1/3, and we can check it. Multiply 3 times 2, which is
6.
6 plus 1,
7.
7, and we write it over our denominator of 3. So 2 1/3 equals 7/3, okay?
Okay.
And then we're going to add it to the 1. So when we finish, let me write this here. We had 1 plus 2 1/3. What does that give us? If we add 1 plus the 2, we get
3.
3, and then we have the 1/3. So now, what we're saying is that this expression, 1 7/3, is the same as 3 1/3, okay? Now we're going to move this bottom fraction over because we are subtracting this. So now, this is where we're going to concentrate our efforts on this new problem. The next thing, can we subtract the fraction with the denominator of 7 from a fraction that has a denominator of 3?
No.
What do we have to do, Jonathan?
We have to break it down.
When you mean break it down, do you mean find another denominator?
Yeah.
Okay, when we find another denominator, what we're going to be doing is trying to find a common denominator that 7 divides into with the 0 remainder and that 3 divides into with the 0 remainder. Do you have any ideas of what that would be? Let me give you a hint sometime. We know that 7 doesn't divide into 3 and 3 doesn't divide into 7, correct? Is that true?
Yes.
But sometimes if you multiply the two, you'll get a common denominator. If I multiply 3 times 7, what number do I get?
21.
21, great. So let's try that. We're going to move here. We're going to keep our whole number. And we're going to keep our whole number here. And you said our new common denominator is going to be 21. Because we know that 7 divides into 21 and 3 also divides into 21, correct? Now, this is a 3. What did I multiply this 3 by to get my new denominator of 21?
7.
7. So if I multiplied 7 times the 3, I also must multiply the 1 times 7. What do I get when I multiply 7 times 1?
7.
Great. Okay, now let's look at the other fraction. We know that 7 divides into 21 how many times?
3.
3. So then I multiply the numerator by that same 3. So 3 times 1 would be
3.
3. Great. Now let's check and see if we're ready to subtract. We have common denominators, 21, and we have our whole numbers. And can we subtract 3 from 7?
Yes.
Okay, and when we subtract 3 from 7, what do we get?
4.
4. And what is our denominator?
21.
21. Now we can subtract 2 from 3, which gives us
1.
1. So far, this is our answer. Can we reduce this fraction any more than this? In other words, can we divide a number into 4 and a number into 21 that reduces this any further?
Not that I know of.
You're correct. We can't. This is the end of it. But the important thing is, I use this because this was odd. Most of the times when we get a problem, we have a problem where the numerator is smaller than the denominator. So that's why this was such a unique problem. We had a larger denominator, which meant we had to do something else before we were able to subtract.
And isn't the bottom one the denominator?
What did I say?
Yeah.
I'm sorry, dear. Thank you you are very attentive. We had a larger, the numerator was greater, I should have said, and usually it's the other way around. Okay?
Okay.
So you did a very nice job. Do you do pretty well in fractions?
At school?
Yes.
No.
No, what? You fooled us. Maybe your teacher's watching. She sees that you have been able to follow through with this problem, which was kind of difficult for a 5th grader who's just beginning in fractions, okay?
Okay.
So thank you very much, Jonathan, for agreeing to do this problem live for us today.
All right, thank you.
Bye-bye, dear.
Bye.
Let's give him a round of applause. Okay? Okay, Jonathan. Let's move over to another question that was called in by Maria, who's in 9th grade. And Maria's working on radical expressions. And for this particular radical expression, 8a to the 12th power, b to the 8th, b, c squared. What I want to do is rewrite this and tell you something about, first of all, I'm going to write the 8 as 4 times 2. The reason, I know that 4 is a perfect square and I can take the square root of that. And whenever you have an exponent, you take half of that exponent. So I'll write a to the 12th is a to the 6th, a to the 6th. That gives us a to the 12th. And for b to the 8th, we're going to write that as b to the 4th, b to the 4th. And then we have an odd b there. Write that. And then we'll write c squared. And the reason I did that is because you can take one of these out and you'll see what happens. So we take the square root of 4, which is 2. That goes outside the radical. We take the square root of this, which is one of those, which becomes a to the 6th. So we take care of that. The square root of b to the 4th, which would be b to the 4th. And we have we have another b that's here, and then we have c squared, which would be c. So I took out all the perfect squares. 2a to the 6th, b to the 4th, c. Now we can go back, and anything that's left under the radical, which is a 2 and this b, tells us that those are not perfect squares, and so that remains inside the radical. So now we have 2a to the 6th, b to the 4th, c, radical 2b. Again, when you're taking the square root of even exponents, this is what happens, and you take that out. So this is your final answer, and you can readily see what's left under the radical because I circled those. So this is the way you go about simplifying radical expressions. Move over to the next question, called in by George, who's a 9th grader. And George is working with factoring. And he had several problems on factoring. Let's look at his first factoring problem. When you're factoring, we always tell you to look at each of your terms to see if there's a common numerical coefficient and or a variable that's common to all of the terms included in your problem. Here, right away, if you know your factors of 5, you can realize that 5 can be factored out. So we factor out a 5, leaving us with x squared. 25 divided by 5 gives us a negative 5x, and that gives us a negative 6. At this point, you look at your trinomial that's inside the parentheses to see if we can do any further factoring. And here we have a trinomial. Let's see if we can factor this as 2 binomials. First of all, x squared would be factored as x and x. Next, we go to the last term, which is a negative 6, which tells us that we're going to subtract. One term is going to be positive and one term is going to be negative. The factors that will give me a 6 when I multiply and will give me a difference of 5 would be 6 and 1. So now, the minus sign at the end. The only way that I can get a minus sign as my last term is that one of these is going to be positive and one is going to be negative. If I go back to my middle term and see that the difference is negative, I know that the greater number has to be negative, and this would have to be positive. And always check that. We check that middle term. That's the one that always causes us trouble. So if I multiply the negative 6 times x, I get a negative 6x. If I multiply x times 1, I get a positive 1, which gives me that negative 5. And so this is your factoring for this particular problem. He had one other problem for factoring. Here we have 2 terms, but we go about it the same way. We look to see if there are any common factors, and right away I see that an 8 is common to both of these terms. So we're going to factor out an 8, leaving us with, okay, once we factor out the 8, we have m squared minus 9n squared. If you're not sure about it, just multiply this again. 8 times m squared gives us that term. 8 times the negative 9 gives us that negative 72 again. So we factored out the correct numerical coefficient. Next, you'll notice we have 2 terms, but there's something unique about the 2 terms. This is a perfect square, and that's a perfect square. So this is called factoring the difference of squares. We keep this factor of a, and now we're going to factor the difference of squares as 2 binomials. First, we take the square root of the first term, which will be an m squared. So we put an m, both parentheses. Now we look at our last term. We're going to take the square root of 9n squared. The square root of 9 would be a 3, and the n squared would be n. And remember before when I talked about that last term, which was the negative 6, the only way we can get a negative now is one of these has to be a positive and one has to be negative. And that's the way you always factor the difference of squares, and you also keep that factor that's outside. So this would be your final answer. Okay, the next question I have was called in by Letitia. And what Letitia's working with is percent. Her question was, what percent of 56 is 42? And when we're dealing with questions like this, we usually give students this little fraction here, is divided by of. And so we can then find our numbers. Is in this instance would be 42. The of would be the number that precedes of. So is of equals the percent over 100. instead of doing the percent, what I'm going to just change it for is the letter P, and we think about percent. So what we have now, when we put our numbers into place, what we'll end up with is a proportion. So is represented by the 42, of would be the 56, equals P over 100. So in multiplying, but before we multiply, we might be able to reduce this a little bit, and we can do 14. 14 divides into both of these numbers. 14 divides into 42 3 times. It divides into 56 4 times. So we have kind of reduced that. So now we have 4P equals 300. Oops, excuse me. Yeah, 4P equals 300. And we can carry it on. And we end up that the P equals 75. And remember we said P represented the percent. So this works out to be 75%. So what are we saying? We're saying that 75% is 42 of 56 gives us 75%. And so that works out to be your answer. And that concludes my math segment today, but stay tuned for Robert with 15 more minutes of math and another clue for that puzzle.
Thank you very much, Doris. Let's get started. Let's get started with the clue. All right, my clue for today is I am tall, slender, and unmarried. Hector, is this a joke? I think this is a joke. No, it is the clue. I am tall, slender, and unmarried. It seems like a good time to remind you that the number for Homework Hotline is 1-800-LA-STUDY. Doris's clue was, let's see now, which one was Doris's? I first appeared in 1887. So that was Doris's clue. I first appeared in 1887, and I am tall, slender, and unmarried. Okay, those are the two clues. Now, before we get going here, let me introduce someone by the name of Myra. Myra, can you hear me?
Yes.
All right. And can you see this problem right here on your board in living color?
Yes.
All right. Notice here that it's a right triangle. We see that by this little square we have here, right?
Right.
And it says here A equals 6 and B equals 8. So this distance right here is 6 and right here is 8. Now what we need to do, Myra, is show that the area in area 1 plus area 2 equals area 3, okay?
Okay.
Now, first of all, let's see, how would you suggest that we proceed in a problem like this, Myra? What do you think we need to do first, in your opinion?
Find the perimeter?
The
area?
We could find the area. Well, actually, what we need to know is this side C, don't we? We need to know side C. All right?
Like the Pythagorean theorem?
That's exactly right. Can you tell me what the Pythagorean theorem is?
6 squared equals 8 squared.
Okay, let's write it in the formula form first, all right?
Okay.
All right, we know that C squared equals what?
Equals A squared
Right.
plus B squared.
Very good. All right, C squared equals A squared plus B squared. Now we know what A and B are, right?
Uh-huh.
So we can just fill those in. A is 6 and B is 8.
8.
Right? What is 6 squared, Myra?
36.
36, very good. And 8 squared?
48. 64.
Right, 64. All right, so C squared, what is 36 plus 64?
128.
100.
100.
Yeah. Are you using a calculator, Myra? Just don't use a calculator, okay?
Okay.
You can do this much faster in your head than you can punch the buttons in the calculator, okay? Have confidence in yourself, all right?
All right.
All right. Now, if C squared is 100, what is just C going to equal? In other words, we need the square root of 100.
10.
10, right. So C is 10. So we can replace these right here. A little finger erasing here. We knew that this was A and it's 6. This was B and it's 8. And we found out that C was 10, right?
Right.
All right. Now, if this side right here is 6, Myra, what is the radius of this half circle? If this side were 6, wouldn't the diameter of the circle also be 6?
Yes.
All right. So if the diameter is 6, the radius must be what?
6.
No, that's the diameter. What's the radius?
36.
No,
No?
Myra. This is the diameter of a circle all the way across, right? Can you see this up here? We need to get the camera right up there. Okay. This little circle here, this little line represents the diameter, right?
Right.
Okay. Then what do we call this little thing that's going halfway across the circle?
Radius.
The radius, right. So if the diameter is 6, if this is 6, then what does this have to be?
3.
3, right. So the radius of this circle must be 3. All right, is that clear now?
Yes.
All right. So let's see if we can label that somehow. All right, I'm going to put that right there, come down like this. And can you see that 3?
Yes.
All right. What would the radius for this half circle be?
4.
4. All right, now you're cooking with gas. All right, so we'll put this diameter right here, and we'll label it 4. And what would the radius of this half circle
5.
be? That radius would be 5. All right. Okay, we'll label that one 5, like that. Can you see that all right?
Yes.
All right. Now, can we find the areas of these two semicircles right here? Can you first of all tell me what's the formula for the area of a circle?
Pi r squared.
Pi r squared. Area equals pi r squared. Now let's see, where should we do some work here? Let's do it right down here, all right? So we know that area of a circle equals pi times the radius squared. And we said for this one right here, the radius was
3.
3. So let's see. We can square that 3 and that will give us
9.
9. And in this case, it's going to be 9 pi, right?
Yes.
So this is the area of circle 1, area of semicircle 1. What would the area of semicircle 2 be?
16.
All right, it'd be 16 pi. All right. Now, what is 9 pi plus 16 pi, Myra?
25 pi.
Right, 25 pi. All right. So, we have already discovered that this side is 10, right?
Yes.
All right. Now, and we know that this side, this semicircle plus this semicircle equals 25 pi, right?
Right.
Now let's find the area of this third semicircle. So, what is 5 squared?
25 pi.
That's right. So that one is also 25 pi. And have we shown that 25 pi equals 25 pi?
Yes.
Yes, we have. So it kind of checks, doesn't it?
Yes.
And what we did was this is kind of an interesting little proof for the Pythagorean theorem, isn't it?
Yes.
But usually we say the square of the hypotenuse is equal to the sum of the squares of the other two sides. Let's move over to this drawing over here, all right?
All right.
And let's take a look at this one. This is how you typically see the Pythagorean theorem proved in math books, don't you? In
Yeah.
geometry books. For example, if this is a 3 and there was a square sitting on this side that was 3, that means that 3 squared, or if we very quickly drew all the squares in, there's 9 squares there, right?
Right.
And over here, we could quickly draw in without a ruler. Okay. And we see we have 16 little squares there, right?
Right.
Can you see that?
Yes.
Now, let's see if I can make these fairly even. All right. Then, keeping in mind what we just learned from that other problem, how many little squares would you say there would be over here?
25.
25. That's why we can say, without a doubt, that the square of the hypotenuse, the square of the length of the hypotenuse, in other words, if this is 5 right here, we know that this is 5 and this is 5, and the square of that, or 5 times 5, gives us 25, right? Is equal to the sum of the lengths of the squares of the lengths of the other two sides. The sum of the squares of the lengths of the other two sides, or legs as some people prefer, okay?
Okay.
So this is 3 times 3, or this was
9.
9, and this is 4 times 4, or?
16.
And we saw that the 9 plus the 16 equals 25, right?
Right.
Now let's come back over here and compare it to this other proof that we've done, all right? This is very nice. If it stands to reason if one area plus another area based upon the side of a right triangle works, then maybe we could use the area of some other figure, like a half a circle. And it does work, doesn't it?
Yes.
All right, I think there's some real beauty in that. Do you like that, Myra?
Yes.
All right. Now, that's all I have on this, but I want to talk a little bit about fractions. If you'll have the time, I'd like you to stay with me a little bit, all right?
All right.
All right. Now, first of all, I'm just going to tell you a little story, all right?
Okay.
Now, do you like baseball, Myra? Do you know anything about baseball?
Not really, but...
All right, that's perfect, because I'm going to tell you a little bit about baseball, all right?
Okay.
All right. There was a little league game, and there's this boy named Henry was on this team, and they had a doubleheader. Now, doubleheader means they're going to play 2 games in one day, all right?
Okay.
All right. Now, Henry was a pretty good batter. That means that when the ball is pitched to him, that he can hit the ball pretty well, okay? So in this particular day, in the first game, Henry was 2 for 3. That means he was up to bat 3 times, all right? He was up to bat 3 times, and of those 3 times, he had 2 hits. He had 2 hits, okay? So Henry was 2 for 3, all right? Now we could also write that as a fraction 2/3, okay? You understand that so far?
Yes.
All right, now here's the second game of the doubleheader, and in the second game, Henry was only 1 for 4. Okay? He was 1 for 4, right? And we could write that as a fraction like this, 1 for 4, right? Now in those 2 games, how many hits did Henry get all together, Myra?
How many?
Yes. In the first game, he got 2. In the second game, he got 1. How many hits did he get all together?
3.
That's right, Kim. He got 3. Okay. Kim just held up the sign that said 3 minutes there. I thought she was answering the question. So yes, he got 3 hits. And how many times was he up to bat there?
12?
No.
No, wait.
Careful. He was up 3 times in the first
3
game
times.
and 4 times in the second.
7.
7. So that means for that day that Henry was 3 for 7, right?
Right.
All right. So can we say that if he was 2 for 3 in the first game and if he was 1 for 4 in the second game, that for the day he was 3 for 7, right?
Right.
Right. But if you did this on your math paper at school, your teacher would mark it wrong, right?
Yes.
Do you know why?
Yes.
Okay. So there's kind of a little fallacy here because this is absolutely true. This is perfectly true what we have here. Henry was 2 for 3 and he was 1 for 4, so altogether, all right, altogether he was 3 for 7, okay?
3 for 7.
Now, so what we need to do is to look at it the other way as well, okay? So the other way that you would do it in your math class would be to find the common denominator, right?
Right.
All right. And the common denominator here would be 12, and this would be 8/12, and this would be 3/12, and altogether that would be 11/12, right?
Right.
All right. Now, Myra, how could you describe the fallacy here? Or how could you describe why it turned out differently? What would you do to talk about this? What could you say? How would you justify the differences in these answers to somebody if they were asking you this question?
Oh, well.
You don't know what to say, huh?
No.
Well, we know this is true, right? If he was 2 for 3 and 1 for 4, he was 3 for 7, right?
Right.
All right. And if he was 8, and if we had, for example, if after the game they went out for pizza, and Henry ate 3/4 of the pizza, and his coach ate 1/4 of the pizza, altogether they ate 11/12 of the pizza, right?
Right.
Now, both of these things are true, but we have to be careful in our notation. That's kind of the point of this. We have to be careful in our notation. This is correct notation, but we have to be a little bit more careful when we're talking about here. Here, that's one of the reasons why we have batting averages, all right? Now, this batting average right here, and this would be a batting average right there, and then we would have that average all together. Now, before we go on, Myra was pointed out to me, we made a little mistake in this problem right here. We talked about it as if it were a whole circle. Now, it would still come out correctly. The thing we forgot to do was divide all these circles by 2, okay? But since we divide everything by 2, it still turns out to be the same, okay?
Okay.
But it was pointed out to me, and we better correct that right away, because we used the formula for a whole circle here, didn't we?
Yes.
Okay, we should have divided it by 2. Myra, thank you very much for your help. That's all the time that I have, so thank you very much, and stay tuned. We have another 30 minutes of English coming right up.
Well,
Hello.
Sometimes
Hi.
you go first.
Welcome to the homework
go
section
first?
of Homework. Oh my God, the English section of Homework Hotline. I'm Catherine Webb.
You're an English teacher.
They say.
Yeah, I think so. And I'm Jose Hernandez. Welcome to the English segment of Homework Hotline. You
Yes.
just finished with the math segment, and now it's the English segment. Do you ever get asked if you're the math teacher on Homework Hotline? Do you ever find that happens? People run
Yes.
into me and say, "Oh yeah, you teach math on."
And I am duly insulted.
Right. I say, I look at them and give them a cold stare and say,
And then we
"No."
recite something.
Right. Some fabulous poem or something.
And what are you doing today,
And
Jose?
speaking of reciting, I'm going to do this first. Remember that today we have clues for our where in history is Carmen, or who is Carmen San Diego? Or
Yes.
Where is Carmen San Diego? One of those.
Where is she?
Where is she? Well, see, no. Today, Carmen San Diego is a person. And I'm gonna actually deviate a little bit and say it's very appropriate literature here.
Right,
Very
that we
appropriate
do
that
it.
we, English literature,
Give you the clues.
Give these clues to you who read out there.
Right.
Read
and
books.
you have read about this man.
Mm-hmm. See, we're giving all kinds of clues. You
Now, what's the real clue?
Okay. First of all, the first clue was I first appeared in 1887. The second clue, I am tall, slender, and unmarried. And now for the third clue, I'll be giving you the third clue. I appear in bookstores, but don't sign any autographs. I appear in bookstores, but don't sign any autographs. Good luck. And today, speaking of literature and things like that, I'm going to be doing a poem with a young lady who has an assignment in terms of interpretation, and so we're going to take this opportunity and talk about it. It's a pretty interesting poem, and also maybe talk a little bit about resume writing, especially for our 12th graders out there. The summer is around the corner.
Get a job, okay?
Hey.
And now, I am going to be discussing with a young woman foreshadowing. And flashbacks. We're going to read a small piece of literature, and we're going to talk about a final project where it is submitting your best piece of writing for publication in a magazine.
Wow.
Yeah, the class is going to publish, and you have to submit one.
Hot stuff.
Oh, indeed.
And remember that if you have a question, you can call us up at 1-800-527-8839
Or simply dial 1-800-LA-STUDY.
Great.
And it is free.
Right.
Okay.
All right, thank you.
You're welcome.
Okay, I believe that I have my caller on the line. Is that true?
Yes.
Okay, and would you introduce yourself?
Hi, my name is Tina Magwood, and I go to Westchester High School.
Okay, and Tina, you're a 12th grader, is that correct?
Right.
Tina had a very interesting poem that I have behind me, and we're going to go through that. It's kind of a writing assignment. But prior to that, Tina, because you are a 12th grader, I thought that it would be very appropriate for us to take maybe a few minutes and discuss very quickly on how to put together a nice resume. Do you know what a resume is, Tina?
Yes.
Okay, let's define that for our people out there. What is a resume?
A resume basically is something to help you find a job. It tells the people about your job, about what you do, your different characteristics in trying to find a job.
Okay, very good. In fact, yeah, a resume is basically a way of letting a prospective employer know what kind of experience you've had and what you can bring to that particular work site. So I want to talk just very briefly about some of the aspects of a good resume. It used to be, Tina, that a resume, we who were out there trying to find a job would try and fill pages and impress people and say, wow, look at my resume, it's 5 pages long. Look at mine, it's 10 pages. All, just go on and on and on. Now, do you know currently what today's restraints and all that, what today's resume looks like? How many pages is today's resume?
Basically, it can be 1 page.
Very good, Tina. A good resume should be about 1 page. Now, why is that? Why do you think it should only be 1 page?
Basically, probably because you only need 1 page to put a list of things on the paper. You don't really need too many pages, because it's more or less like going on bragging after that.
That's a very good point. You're absolutely right. And because today employers are very busy people, generally speaking, and they have other things to do.
Right.
They only want to look at one page. They want to get all the essential information down on one page, so really that's all you need. Now, on a good resume, what do you think should be like the first thing that someone sees?
Your name.
Right. So a good thing to do is to center your name, address, and of course, very importantly, what?
The
Do you see what I'm writing? And your
Phone number.
Right, your phone. Put that on the page because, you know, that's what's, you know, and if you have a computer or access to one, it would be nice to try and use different type settings to make this maybe a little bit larger than the rest of the resume. Now, the resume should be divided in different parts. What sort of parts should the resume be divided into?
List of different sources to help find to help you with the. I'm trying to figure out.
Okay, now remember, where the employer is seeing this, what does the employer want to know? Let's do a little brainstorming here. What does the employer want to know about you?
More or less your background on your age.
Okay, know your, can we use the word experience?
Experience, right.
Okay, the word experience in terms of jobs. Okay, so experience, jobs that you've had. What else does an employer want to know? If he's going to be putting, you know, giving you a salary and putting money into you.
Maybe education.
Very good, exactly, yeah. The employer wants to know that you have an education, you know, so go ahead and put down your education on there. And then another thing that might be a good idea to put on the resume would be what else? Job experiences, education.
How about some resources of people, other people that can back up your job?
All right.
References.
Yeah, references, all right. References would be something else. Anything else you can think of that might go on a resume?
Maybe your activities or maybe awards. Maybe activities.
Okay,
More or
and
less
you know,
awards.
we can actually do both, can't we? We can
Right.
put, we can even just have a section saying additional information. We can say hobbies. We can put skills as a different area. Now that's kind of a lot to put on one page, but we can do that. We can. Now, what do you think of all of these is the most important to put first? We have job experience, education, references, and additional information.
Well, experience in jobs is important.
Right. You got it.
So is references.
Okay, so let's say that the first part of the resume would be experience, and we can even say that on there, experience. And then we should list, a good idea would be to list in chronological order, the jobs that we've had. Chronological order, the jobs, with the most recent, the latest thing that you did going down into the past. Okay, and that's a typical setup for a resume. I should say that there are many ways of doing a resume. This is just a quick one, and again for seniors in particular, but not only seniors, the rest of you in high school and maybe junior high who are out there looking for a summer job, you might want to put all of this together, and this can also help you if you walk into a job, you can have a reference to do the application right then and there in front of the employer or whomever and get it done, turn it in right away. Okay, so we've got experience. That's the first thing we want to put. Then, of course, I think we should go ahead and, don't you?
Yeah.
We'll put education.
Education.
Yeah, and then we can list, you know, what, and not only the high school that you go to, but also any other sorts of education that you may have had. Summer camp or...
Impact programs.
Exactly, very good. That would be an excellent thing to put down, you know, as education. And typically, I'll tell you, references, you're right, is important, but something that can be done is that you can have a separate sheet, excuse me, a separate sheet that could be, because usually references take up a lot of room. So we could have a whole different sheet just with references, and on the bottom, what's really nice is that we put references available. Okay, and we let and I'm just going to abbreviate, references available. You can put that at the very bottom of the resume, and that way it gives you a little bit of room to list special skills / hobbies. Okay, so now really, and if they do ask for references and you've got it ready and you can submit some real good references without having to worry about a space limitation. So anyway, that's something that I did because you told me you were a 12th grader. Let's get quickly into your assignment and see if we can draw something from it. Now, as I read this poem, Tina, I want you to know that I was looking at the tone and also looking at the decisions that the poet made in writing this poem, because I think tone, for me, tone was very important in this poem. Let's read it together. In the desert I saw a creature, naked, bestial, who, squatting upon the ground, held his heart in his hands and ate of it. I said, "Is it good, friend?" "It is bitter, bitter," he answered, "but I like it, because it is bitter, and because it is my heart." And of course, the assignment then was to discuss the significance to human action found in the image of the heart. So the image of the heart is very important here. Let's talk a little bit about symbolism. What is symbolism, Tina?
Symbolism is basically, let me see.
Using one thing,
a
symbol, to describe
the other.
To describe a feeling.
A feeling.
A feeling. Now, the human heart has been often used as a symbol. What is it a symbol of? What kinds of things? What do you think when you see a heart? What do you think of?
Feelings.
Feelings. Excellent. Feelings. Okay, so feelings is something that is very important to this. Okay, so, and then speaking of symbols, is it important that it's the desert that he's talking about?
Yes.
Okay, it is important. The desert, loneliness. Okay?
Right, okay, I see.
Do you see that?
Yeah.
You see how it's coming out? Loneliness, feelings. Now, what is this creature? What is this creature? What type of creature is this thing in the desert?
To me, it seems like he's lonely, and he seems like he's different from others.
Okay, now, are we talking about a regular animal, or are we talking about a very special animal?
A very special animal.
Okay, are we talking about a human being, or are we talking about maybe, a chimpanzee or something?
It sounds like it's a human being.
A human being. Now, the human being is eating of his heart. He's lonely, he's eating his feelings, and what sort of picture does that conjure for you? What is the significance of that?
That he's eating his feelings?
Yeah, that he is somehow, involved in sort of eating of himself. He is destroying himself, isn't he?
Right.
He is destroying himself, and so that's very important. That, sometimes, again, we have to compare actions, the significance of the human heart to actions. What sorts of actions do we do that destroy ourselves? What kinds of things do we do? What would be an example of someone who, through his actions, destroys himself?
Through his action to destroy himself. Well, we hurt ourselves in a way of curing our sorrows.
Okay, we do. For example, someone who may have a problem,
right,
rather than deal with the problem, brings that hurt inside and kind of eats himself up. And is there any other creature that really chooses to destroy itself?
No.
No. So this is all part of it. The human animal is among the only creatures that chooses and gets some sort of a strange pleasure, maybe. Pleasure is not a good word. We'd have to think more about it. But I wanted to at least start you off in being able to write a composition about this. So we have some important elements. Let's review. Significance to human action found in the image of the heart. He's eating of his feelings, and we could discuss the symbolism of heart more. He's lonely. He's eating upon his feelings. This is a creature, but it's really we're talking about a human being. So he's eating of it, and he says it's good. Now, eating the heart is good, so there's something there to explore. And you said
right,
sorrow, and I think that's a good word.
Right,
sorrow is all part of this. Now, I know we didn't have time to discuss this because this really has a lot in it. But Tina, I want to thank you because you have really given us all a very good poem to think about, and the fact that there may be better ways of dealing with your sorrow than going inside and eating of your heart, to put
right,
it in metaphor. And I want to thank you, Tina.
Okay.
That's all the time that I have, but we have 15 more minutes with my teaching partner, Catherine Webb.
Thanks, Jose. And I have the pleasure of saying that we have a winner in the contest. And it's Jonathan from Reseda. Are you there, Jonathan?
Yes, I am.
Wonderful. What gave it away for you?
The clue about literature narrowed it down. Instead of thinking of politicians, I started thinking about literature. And I came up with Sherlock Holmes.
Yeah, exactly. Congratulations for you.
Thank you very much.
Okay, do you hear us applauding you? Yeah. Do you read a lot of Sherlock Holmes?
Some. I used to. Now I just watch the movies.
Oh, wonderful. Yeah. Well, good. So you have this wonderful background from all of your reading now, so you understand all the nuances better, right?
Exactly. The literature is the key.
Yes, it is. Well, thanks a lot, Jonathan. And we will be calling you back. You did leave your telephone number and all of that information, correct?
Yes, thank you.
Okay, and congratulations.
Thank you.
Keep looking, okay?
Okay, I will.
All righty.
Bye.
Okay. All right. And now my call isn't ready yet, but what we're going to do, we're going to set the background for the information that I'm going to do with another young woman who volunteered to do the assignment that someone else would not do on the air with me. So while we're waiting for her, and she's on the air now, hi, Stephanie.
Hi.
How are you?
Fine.
Great. What I was doing, Stephanie, was I was telling the audience that you have volunteered to do someone else's work with me today, okay? And I was about to walk over to the board and show them the assignment. So I will do that, and then you and I will get started, okay?
Okay.
All right. So if you'll look with the remainder of the audience, we're going to learn about some things that's being done in the teaching of English right now, okay?
Okay.
In this particular one, it's, final time, where everyone's doing those final projects and reports. Are you doing one yet? Okay, well, maybe we'll talk about that too. Well, in this one, this class is going to publish a magazine of the writings that they're doing in their class. And as you see in this one, you get to choose what you want to have printed in the magazine, okay? This young woman chose to write a short story, and she's going to develop her story using flashbacks. Now, you remember I told you, I know this is something new for you, but we're going to work at learning it today, okay?
Okay.
All right, so with that in mind, let's read what a flashback is. Read for me, darling.
Current action explained by events and
Go ahead.
actions that took place in the past.
Okay. Now, what a flashback is, something that's happening now with an individual. And what is happening now is based on a past experience, okay? Now, I want you to look over here. And you notice we have flashback subjects, some ideas. When she and I were talking, we were trying to decide, because this is an original story, okay? And we had to decide, well, what could she write about? So here are some subjects for a possible story that's grounded in the idea of something happened to me in the past, and it's making me behave the way that I behave today. So you understand flashback?
Yeah.
Okay, now let's look at some of the subjects. Can you read this one?
Fears.
Okay, and what are some fears that I might have from a past experience that might make me behave strangely? Fear of?
Height.
Dark.
Animals. Specific studies.
Situation.
Of situations.
For example, being in what?
Elevators.
Okay, if I've had a bad experience and I have fear of any of these, when I'm in an elevator now, I might behave in a way that's grounded in what happened when I was in an elevator 12 years ago, because I can go back into my mind and I can feel and see and experience that, okay? So that's one thing. Look at another that we could do. Go ahead.
Jealousy.
Okay, read this part first.
Seemingly unreasonable behavior.
Okay, to someone watching me, I may appear unreasonable in my behavior, okay?
Okay.
Because I may be acting with
Anger.
I may be acting with,
Jealousy.
I may be,
Crying.
and I may be,
Refusal to participation.
Right. I'm refusing to participate. I'm standing there crying. I'm angry. I'm jealous of someone. Don't want to be a part of something. And someone right now in this time would know, well, why is she acting that way? When in my head, I'm going back to an earlier event, flashing back, okay? All right. You ready to read?
Yeah.
Okay, let's read, and then we'll go back to the other questions. Now, can you see this on the on your screen?
Yeah.
Okay, can you see it clearly?
Yeah.
Okay. What if I do it like that? Is that even, hold on now, is that better or worse?
Better.
Okay, read to us.
Monica was excited as she and Lisa hurried up the front steps to Dina's house.
Mm-hmm.
This was the first party she had been invited to since she had moved to Glenville 3 months ago. At first she had had trouble making friends, but now she felt that she was a friend of one of the most popular girls in school, Deanna Sanford. This is going to be a great party, Lisa said as she rang the doorbell. Dina's parents aren't home.
Okay, now we have two girls, right?
Right.
Okay, what two girls?
Dina and Monica.
Okay, and Lisa now. I'm sorry, darling, we have three. Okay, go ahead.
The way she said that bothered Monica, they're not. No, isn't that fantastic? Fantastic. Before Monica could answer, Deanna opened the door and greeted them. Several kids were already there. Music blared from a stereo and kids were dancing. It was a lot louder and wilder than Monica thought it would be.
Okay, take your time.
She mingled with the other kids who seemed glad that she had come, that Monica felt
Take your time.
feel accepted.
Okay, read it again.
She mingled with the other kids who seemed glad that she had come, that made Monica feel accepted.
Okay, and we remember Monica is new to this town, right?
Right.
And this is her first big party at the girl's house, okay?
Mm-hmm.
All right, go ahead.
Just as Monica was starting to relax, Dina emerged from the kitchen.
Whoops. Okay.
With several cans of beer on a tray. Here's what everybody's been waiting for, she announced. Monica watched her friends crowded around Dina eager for a can of beer. Monica's mind flew back to the same scene in her former town. There was drinking at that party too. She recalled how she and her best friend Stacy had become drunk, and then walking home, Stacy had been hit by a car. Remembering the flashlights, the sirens, and questions and explanations made her shudder. That Stacy had recovered made little difference to Monica now.
Mm-hmm.
When Dina handed Monica a can, Monica shook her head. "Oh, come on," said Dina. "Take one. You won't get into any trouble." "No," Monica said. "I don't want any." She headed to the closet to get her coat. Pulling her coat on, she left.
Okay, now, all righty. Think back to what we said just a few minutes ago, okay?
Mm-hmm.
Now, who are the girls in the story?
Monica,
Uh-huh.
Dina, and Lisa.
Okay, Monica, Dina, and Lisa. You know what the word setting means?
Nuh-uh.
Okay, setting is time and place, location for a story, okay?
Okay.
What's the setting?
The party?
That's right, the party at Dina's home, okay? So we have Monica, Lisa, and Dina, and they're all at Dina's home, okay? And they're having a party. Now, what event happens that Monica remembers? What is she remembering that took place before?
Her friend getting hit by a car?
Right, her friend got hit by a car. What preceded her friends getting hit by that car?
Her drinking beer and getting drunk.
Right, they drank beer at another party and they became drunk, okay? And then on the way home, her friend was hit by a car. Okay, now what caused Monica to go back into this time, to flash back to that event?
When they were bringing out the trays of beer?
That's right, when they brought out the trays of beer, she started remembering what had happened at the previous party and she flashed back, okay? How does she handle it now?
She said, no, because she might have got hit by a car, something could happen to her, and then she just left.
Okay, she told them no, she refused the beer, and she left. Okay. Was this an easy decision for Monica to make?
No,
Why not?
because she probably didn't want to disappoint her friends.
Okay, she didn't want to disappoint her friends. And what else do we know about Monica in this town?
That it happened once before.
Okay, no, this town where she is now. What did we learn in the beginning when the author was telling us about Monica in this town where she's living now? What made this a difficult decision? One, she didn't want to disappoint her friends. Were these friends she'd had a long time?
No.
Okay. What do we know from information the author gives us at the beginning about Monica's length in this town?
That she was only there for 3 months.
Right. She's new to this town. And why is this a special party?
Because she's barely coming there.
Yeah, right. You don't have to say it soft, say it strong. Right. Come on, why is this important?
Because she's just barely going to that town.
That's right. She's new to this town. She's in, what grade do you think she is?
7th.
Okay. So she's like you, huh?
Mm-hmm.
Okay, she's a 7th grader. So we'll say she's a teenager. How's that?
Fine.
Okay, fine. Good. So we know she's a teenage young woman. She's new to the town, and Dina is the most popular girl, okay? And there she is at this great party. They offer her beer, and it triggers something in the back of her mind, and she remembers a past event. That's a flashback. Make sense?
Yeah.
Okay. Did you notice how smoothly right in here the author, I'm trying to make sure you can see this on the screen because we're going to go back to the screen for a moment and point out how the author just quickly eased into the idea flashback. He didn't say Monica had a flashback. He said Monica's mind flew back to the same scene in her former town, okay? All right?
Yeah.
I want to thank you for helping me out, Stacy, because you did it on the spur of the moment like that. Thank you very much. And call again, okay?
Okay.
All righty. That terminates my time today and Homework Hotline today. We will be here tomorrow, however. Take care.